this video we will look at exponential functions, but we will use a table to first determine the basic shape of an exponential function. The standard form of any exponential function will be this: y equal to b, that is just a constant, times a to the power of x plus q. B is never 0 and a in this case is positive. This is our first type. Then we have another type 2 where a is in between 0 and 1. We will never consider negative a's because otherwise we will have, for instance, minus 1 squared, which is plus, and minus 1 to 3, which is negative. So the function will jump. So it will be something like this, and we can't have a continuous line through that. So in all of the cases, a is positive, strictly positive, not even 0, because if it's 0 then we just have a constant function. So a is strictly positive, greater than 0, and in this case a is greater than 1. For type 2 we have fractions in between. If a is larger than 0, less than 1, then we have a fraction. So for instance, if a is a fraction, then we can write it as 1 over a, where a is still greater than 1, like in type 1. And then I can just rewrite this a 1 over a as a to the minus 1, and then I get a to the minus x. In this case, we can now again write x greater than 1. I prefer this form. Now, always write my exponential equations rather as a to the minus x, and not like this where a is a fraction. So in this case, I will rewrite type 2 as y equal to b times a to the minus x plus q. B is not 0, but b can be negative and positive, and fractions, it doesn't matter, anything except 0. And a is greater than 1. So let us look at the first type 1, a table for type 1. I have just used the function y equal to 2 to the x. So a is 2, which is larger than 1, which we require for type 1. And in this case, I can work out the values from minus 3 to 4, substituting in this equation y equal to 2 to the x. If I work this out, I get 2 to the minus 3, that is equal to 1 over 2 to the 3, and that is 1 over 8. If I work out 2 to the minus 2, I get 2 to the minus 2, and that will be a quarter, and 2 to the minus 1 will be a half. 2 to the 0 is equal to 1, 2 to the 1 is equal to 2, 2 squared is equal to 4, 2 to the 3 is equal to 8, and 2 to the 4 is equal to 16. And we label these points, the point minus 3, 1/8, we label it A, and minus 2, a quarter, we label B, etc. So on the graph below, you will see that I've plotted these points. So here I've plotted point A, which is minus 3 and 1/8, and then we have minus 2, a quarter, and minus 1, a half, and at 0 we have the value 1, and then it increases until we get to the point H, where we have 2 to the 4, which is equal to 16. So if I zoom into this graph a little bit, you can see the values there. And you will see everything where x is negative will be below this line y equal to 1, because the y-intercept is y equal to 1, and that's a very important point on the exponential function. If I now draw a graph through these points, then this is how my graph will look like. If you look here to the left of A, it looks as if that green graph intercepts the x-axis, but that is not true. If you zoom in there, which is not possible on the screen, if you zoom in to the left, you will see that it will never touch the x-axis. So we will see in the next example that we have a horizontal asymptote here of y equal to 0. If we now look at the second part where I have a fraction, 1 over 2 is equal to 2 to the negative 1, so therefore I have 2 to the minus x, which allow me again to have a greater than 1. And then if I substitute that into my table, I will now have 2 to the minus 3, which is equal to 2 to the plus 3, which is 8, and 2 to the minus 2 will give me 4, and 2 to the minus 1 will give me 2, and 2 to the minus 0 is the same as 2 to the plus 0, which is equal to 1. Then here we have 2 to the minus 1, that will give me a half. And here I have 2 to the minus 2, that is equal to a quarter. 2 to the minus 3, which is equal to 1 over 8. And 2 to the minus 4, which is equal to 1 over 16. Again, I've labeled the points. So here we have minus 3, 8, minus 2, 4, minus 1, 2, 0, 1, 1.5, etc. So I've plotted this on the graph, and then if I plot the points, I see now we have a decreasing function. The other one, 2 to the plus x, was an increasing function. Now I have values keeps on decreasing. But important again, the y-intercept is equal to 1. On the right hand side, I've just joined the points, and you can see it is decreasing quite rapidly here until 1, where it crosses the y-axis, and then it goes nearer and nearer to the x-axis, but it never reaches the x-axis, because you cannot have an answer of 0, because even if you have 2 to the negative 1,000, then it's still not 0. On this table, I've just used the previous two tables and I've joined it to show you the relationship between 2 to the x and 2 to the minus x, or the relationship between a to the minus x and a to the x. If you look at the point A there, I've labeled this point here a prime because I get the same y value here as I had for minus 3. And this was at minus 3 and this was at plus 3. And then the next one is when I go to minus 2, I get a value of a quarter, but I will get that again at plus 2 and a quarter. And that's why I labeled it with a prime. So this A corresponds to that, this B corresponds to the B prime, the C corresponds to the C prime here, etc. And that will result in the graph y equal to a to the minus x is a reflection in the y-axis, or the mirror image of this y equal to ax in the y-axis. Here I've plotted all the points and the two graphs, 2 to the minus x and 2 to the plus x. This is just an example of a reflection. It doesn't prove that it's also always like this. It does not prove that it's always true. But, so let us label a to the minus x, f of x, and a to the plus x, g of x. Consider g of minus x. If I put g minus x into this function here, then I replace my x with a minus x. So I'll have a minus x. But this is exactly f of x. So that means that g of minus x is the same as f of plus x. Or if I do f of minus x, I'll get a to the minus x, which is a to the x, which is g of x, and that will prove that the one is a reflection of the other one in the y-axis. We rarely work out a table for even an exponential function. We will work out the y values at -1, 0 and +1 just to compare the graphs, but this table that we did here is just to show you more or less, or to convince you that that is a shape of exponential function.